Guys, we'll try to solve this numerical which says that a simply supported beam of I section. So section dimensions are given here, and it's simply supported this way. So simply supported means it looks like this. So we are trying to draw this diagram so that we can actually picturize what is being written there. A simply supported beam of I section. It is a I section which is shown here. Carries a UDL of 40 kilonewton meter, which runs through the entire span of the beam. So that means there is a UDL acting throughout. So there is a UDL acting throughout the entire beam, and that is equal to 40 kilonewtons of load for every meter of the beam. And this beam is of 10 meters length. So that means this. So it is simply supported at the ends. It's simply supported, and they are not certain whether it is overhang or something. So therefore, assuming that the supports are at the ends, we are solving this. Sometimes some assumptions are made so that there is no confusion. It is simply supported at the ends. Ends are not written. So, but we are still considering that the supports are at the ends. And its I section carries a UDL of 40 kilonewton per meter, which runs over entire length of 10 meters. If the dimensions of I section are shown, as shown in the figure, determine the stress produced. Now, we'll see how do we go about the problem. So, what is the formula that we have to use? We have to find stress. Okay. Now, we can use this formula. May I? So, we are supposed to find this. We are supposed to find this. So, we can find the moment of inertia of the I section itself. Okay. And then Y is known to us. Then we can find out M. M for this case we know. That is, we have seen 4 cases. We have taken 4 cases earlier. Cantilever with UDL, cantilever with point load, simply supported with UDL, simply supported with point load. Okay, in that case, M max is how much for this case? So much is M max. So for this beam, so let me erase this because I can draw this directly below here. So definitely, if I try to draw a bending moment diagram, bending moment diagram will look like this at this end. So here you know that bending moment on the right hand side is 0 because no forces, no moments, it will be 0. And bending moment on this side is 0. And bending moment at the center is how much? So bending moment at the center is, okay, so this is how much. Now the reaction is how much? Basically, total UDL is W into L. W is the intensity multiplied by L will give you the total UDL. Since it is symmetrical, half of the UDL will be taken by left side, half of the UDL will be taken by right side. So here, WL by 2, bending moment, maximum bending moment. You know that it will be like this. You want this M max. So M max will be equal to WL by 2, which is acting at a distance of L by 2, and this UDL placed at the center. This means how much? W into L by 2 basically. So because the whole W for M meters, but it is L by 2 meters, W into L by 2 is the total UDL for L by 2 distance. Acting at what distance? From this point, it is at L by 4 distance. So L by 4 distance, what is the answer here? So it is W L square by 4. This is W L square by 8. We said last time you can multiply this by 2 on either sides. It will become, so 2 into W L square by 8 minus this. So it becomes W L square by 8. So maximum bending moment is given by W L square by 8. So here M max, we'll try to find out M max here. So M max is W L square by 8. So W is, so much is W1? 40, it is given that it is 40 kilo. So it is 40 kilo, please convert that into 10 to the power of 3 newtons per meter. Is that And then guys, now it should be consistent. Later you can do this. Here it is mm. So you can actually convert this into millimeters or meters or whatever to have consistency. L is equal to how much? For 10 meters. WL square by 8. So what is M max now? So here you get this units as Newton. So it cancels out, and finally the unit is Newton meter. Huh? It's 5 lakh. So 500, 5,000, 50,000, 5 lakh. Okay. So it is 5 lakh. M max is equal to 5 lakh Newton meter. 5 lakh Newton meter. Okay. So M is found out here. And then in this formula, M by I is equal to sigma B by Y. So now to find out the stress, M we have found out. Okay. So we need to find out I. So how do I find I now? Or what is the formula for I? For this type of section? So this is capital B. This is like capital B. This is like capital D. This is like, these are like small b, and these are like small d. We need to deduct those two. Okay. So I is equal to, so is it visible? If I write here. So I is equal to capital BDQ by 12 minus 2 into small BDQ by 12. So capital B is how much? So capital B is 200 mm. Guys, if you want, you can convert everything into meters here. Otherwise, you can do it at the end. Okay. So 200 and D cube. D is how much? 360 plus 40, 400. Divided by 12 minus 2 into small BDQ by 12. Small b is how much, man? Can you tell me how much is the small b? Out of 200, how much is gone? 10 is gone. Remaining is 190. So 190 divided by 2 will give you this. 190 divided by 2 is 95 mm. Okay. So here 95 mm is B. How much is D? This D. This is 360. This is small d. So 360. Divided by 12. So you can take this 1 by 12 outside. And this, please find out what's the answer. This will come as a very big number because you are trying to have multiples of 400 3 times. 3279. So this answer comes to be around how much, guys? 3279. 3279. 46. 6. 666. 0.7. So almost like 8 numbers. Huh? So 3279, 4666. Huh? 4 sixes. And then 6 again. 0.7. Okay. So this is mm to the power of 4. This is mm to the power of 4. So here I have found M max, I have found I. So here in this formula which we wanted here, so M by I is equal to sigma B by Y. So let us substitute these values here. So guys, is it visible in the camera? Okay. Now suppose if it is not visible, we'll erase this part. Erase this part here. So M by I is equal to sigma b by y. So substitute this. So m is equal to how much? 5 lakh. 5 lakh Newton meters divided by I. So I is 32. It looks like a 4 number, just one number short. 3279466.7 millimeter to the power of 4 divided by, so it is equal to sigma b, which I don't know, which I have to find, and there's y. Guys, y is equal to how much, man, here? From the neutral axis. Neutral axis will be here usually. So from neutral axis. So this is the neutral axis, and from neutral axis to this, how much is y?
100.
Guys,
180 plus
180 plus
20.
20. It is 200. So it is 200. What man?
D by 2.
So this is D.
Okay.
This is D. So you want the distance here. So D is how much? So 200 mm. So you see inconsistency in units here. Guys, here it is in mm, here it is in mm, here it is meters. So you can't actually do that. So convert everything into meters by multiplying it by 10 to the power of 3 millimeters. So 1 meter is equal to 1000 millimeter. So multiply that. Okay. So when you multiply that, everything is in terms of this. So now you get the answer, sigma b. So usually you get this sigma b, which is usually less than 300. Guys, in the examination, see that these values are not randomly given. This is given by engineers to see that the stresses in the material are within limits. So this should be definitely within 300. Guys, it is a check. You don't have to ask your friends whether the answer is right or wrong. So can you tell me what is the value? So where's your calculator? Why are you not using it?
304.
304.9.
4.9.
So 304.9. It's not exactly, I mean, it's not below 300, but around 300. So 304.9. What is the units? Newton per mm square. So here you have got newtons. Here you got newtons. Here you got. So here you got this millimeter. So then this you can see that when you get cancel this goes this side. It becomes millimeter square, and this cancels out. Finally, you are left with the Newton per mm square. Okay. So it is 304.9 Newton per mm square. So this is how. So usually around 300 or less than 300. So you got this answer as 304.92 Newton per mm square.